Section 13.1, an introduction to polynomials. So here we have an example of a polynomial. This particular polynomial has 4 terms, okay? So everywhere you have like a plus or a minus sign, that's breaking up into another term. So 3x to the 4th is the first term. Negative 5x cubed is the second term, x is the third term, negative 7 is the last term. So you can see we have these in order. We've arranged the terms in the order of descending powers of the variable. So the highest power of the variable is 4, and then 3, and then this would be 1, and this would be 0. So when you have them arranged in that way, then the first term is the leading term, okay, and the whatever the exponent on that leading term is the degree. So I had forgot to notate that on here, but the degree for this example is 4. Okay, so that's the degree. Okay. All right, and so that's the leading term is 3x to the 4th. The leading coefficient then is 3. All right, some special types of polynomials. So if it only has 1 term, that's a monomial. 2 terms is a binomial, and 3 terms is a trinomial. If it has more than that, then we don't have a specific classification for that. Okay, but they're all polynomials. All right. So for number 1, the first thing I want to do is put my terms in order. So it would be negative 4x squared plus x minus 5. So then we can see that the leading term is negative 4x squared. The leading coefficient is negative 4. And the degree is 2, and that would be classified as a trinomial. All right, number 2, 10 minus a. So to put that in order, it would be negative a plus 10. So the leading term is negative a. All right, and there is an invisible 1 here. So the leading coefficient is negative 1. And there's an invisible exponent of 1 here. So the degree is 1. And that's 2 terms, which makes it a binomial. All right. Number 3, we can see that that is a monomial. It's only 1 term. So the leading term is 2x cubed. The leading coefficient is 2, and the degree is 3. Okay. Number 4 is also a monomial, 1 single term. So the leading term is negative 32. Leading coefficient is negative 32. The degree is actually going to be 0, okay, because the degree is the highest power of the variable. So, you know, if you had your variable x here, you would have to have an exponent of 0, okay, because x to the power of 0 would be 1. So that would be like negative 32 times 1, which equals just negative 32, right? So that's what we call a constant term. So the degree there is 0, okay? So if there is no variable, then the degree is 0. That's what we call a constant. Okay, number 5. So let's put this in order first of all. So the first term would be 8x to the 4th Then we'd have plus 2x to the third minus 3x. And then last we have the constant. So the leading term is 8x to the fourth. The leading coefficient is 8 and the degree is 4. And that could not be classified as either a monomial, a binomial, or a trinomial because it has 4 terms. So in that case, we don't give any specific classification for that. All right. Okay, on the next page, we're just going to be adding and subtracting polynomials, which is basically just another way of saying that we are combining the like terms. Okay, so 5x minus 7x, so we're just adding these. Basically these parentheses, I'm just ignoring them because they're not doing anything in this case. So 5x plus negative 7x is going to equal negative 2x. And then negative 11 plus 34 is going to equal, it's basically just the same thing as saying 34 minus 11, so that's going to be 23. So the answer is negative 2x plus 23. Okay. Alright, so number 7, pretty much the same thing. So we're just adding, the parentheses are not doing anything in this case. So 3x squared plus negative 7x squared is negative 4x squared. Then negative 2x plus 8x would be plus 6x. And negative 5 minus 2 equals negative 7. Okay, all right, now on number 8, we are subtracting. So the parentheses on the first polynomial aren't really doing anything, so I'm just going to bring down 5x minus 5, but then I've got to distribute the negative here. So that's basically my first step. So then that's going to be minus 6x plus 3, okay? And then I can just proceed to combine the like terms. So 5x minus 6x, so that would be negative 1x, or in other words, just negative x. Then negative 5 plus 3 is negative 2. Okay. All right, and then number 9, we're just going to combine the like terms. So we also want to have them in order of descending exponents. So the highest exponent I see is x to the fourth, and there's only one of those. So I'm just going to bring that down first. Then next I do see x to the third. Again, only one of those. So I'm just going to bring that down. So plus 2x to the third. Lost my orange pen, so making do with that. Alright, and then x squared, so I've got negative 3x squared plus x squared. So there's an invisible 1 there. So negative 3 plus 1 would be negative 2x squared. Then there's no regular x terms to combine with that one, so that's just bring down the minus 3x. And then I've got 2 minus 5, which would equal negative 3. And that is my final answer for that. Alrighty. Let's see here. Okay, on the next page, we're going to evaluate some expressions, some polynomial expressions. And again, this is something that we've covered previously in the class. It's nothing real new, honestly. So we're going to evaluate this polynomial x squared plus 2x minus 4 for x equals 2. So that means we're going to take that 2 and and we're going to plug it in for each of the x's in the polynomial. Okay, so when I plug the 2 in, I'm gonna have it in parentheses in place of the x. So it's gonna be 2 squared plus 2 times 2 minus 4. Okay. So 2 squared, that's 2 times 2, so that's 4. And then plus, that's 2 times 2, so that's 4. And then bring down the minus 4. So 4 plus 4 is 8. 8 minus 4 is 4. So the final answer is just 4. Okay. All right. Number 11. Same type of thing. Okay, so we're going to evaluate the polynomial 3x squared plus x for x equals -2. Okay, so take that -2 and plug it in for each of those x's. Okay, so 3 times -2 squared plus -2. All right. So, remember your PEMDAS. So, exponents, parentheses, but there's nothing on the inside of the parentheses that we have to actually do. There's only a single number inside the parentheses. So, skip that and go to exponents. All right, so exponents would mean that I'm going to do -2 squared. So, in other words, that's -2 times -2, which would equal +4. Okay, and then I'm just going to bring down the 3. And plus -2 is really the same thing as just saying -2. All right, now next we're going to multiply. So 3 times 4 is 12. 3 times 4 is 12. And 12 minus 2 equals 10. So 10 is the final answer for that. Okay. Number 12, we're going to evaluate the polynomial -x cubed minus x squared for x equal -1. Okay, so take that -1, plug it in for each of these x's. All right. Okay, so this one can get a little bit tricky. All right, so again, we're basically starting with exponents. So all right, so we've got this negative sign right here. We're just going to bring that over. All right, now -1 to the 3rd power. I'll go ahead and just write it out. It's the same thing as saying -1 times -1 times -1. Also, you, okay, yeah, never mind. Yeah, all right, so then we've got another minus sign right here. I'm just going to bring that over. And I can go ahead and do I'm going to write out the other exponent at the same time, I think. So, -1 squared, so that's going to be -1 times -1. Okay, so basically we have, like you could say this is like an invisible 1 there. So, negative times a negative, that cancels. Negative times a negative, that cancels. So 1 times 1 times 1 times 1 is 1. So all this is a +1. Then we could just basically bring that minus down, and then a negative times a negative here. Those cancel out. And so that's a 1. So basically what we have is we have 1 minus 1. And so we would know that that is equal to 0. Okay. All right, and an application type problem here. So for a triangle, we know that all of the like the interior angle measurements of a triangle would have to add up to equal 180 degrees. Okay, so they've given us here a little expression for each of the angles of this triangle. And so I'm just going to write down an equation of basically this plus this plus this equals to 180. Okay, so angle A, that is 3x plus 9. Okay, plus angle B, which is 3x plus 4, plus angle C, which is 8x minus 1. And that is equal to 180. All right. So let's combine the like terms. Okay. So 3x plus 3x plus 8x. So that would be 9 plus 8, that would be 17x. And then 9 plus 4 minus 1, so that would be 13, minus 1 would be 12, so that would be plus 12. And that is equal to 180. Okay. And then let's subtract 12 from both sides. So 17x equals 168. Then I would divide both sides by 17. Oops, okay, I was like, it doesn't look right. I see what I messed up. 3 plus 3 is 6, and I said it was 9. That's where I messed up. Oopsie. And that's magically just got fixed through the magic of technology and whiteout. Alright, so let's see here. So, right, so 3 plus 3 is 6, plus 8 is 14. Okay, so divide by 14. So 168 divided by 14. So 14, we go into 16 one time. 1 times 14 is 14. 16 minus 14 is 2. Bring down the 8. 14 goes into 28 2 times exactly. 2 times 14 is exactly 28. Alright, so the answer is x is equal to 12. Okay, now we're not quite done though, because the question wasn't just to solve for x. They wanted you to find the measure of each angle. So we're going to have to plug that in to each one of these to get the measurement of each angle. Okay, so angle A, which is equal to 3x plus 9. So you're going to plug that 12 in for x. So 3 times 12 is 36, and 36 plus 9 equals 45. So angle A is equal to 45 degrees. And then angle B was 3x plus 4. So 3 times 12 is 36. 36 plus 4 is 40. So angle B is equal to 40 degrees. And then angle C was equal to 8x minus 1. So 8 times 12 minus 1. Okay, so that's 96 minus 1, which is equal to 95 degrees. That's angle C. Okie dokie. So, and if you add those up, you'll see that that does in fact add up to 180 degrees. All right. The end.